Hello, trigonometry. Just gonna give you a brief lecture over section 5.1. 5.1 is really an introduction to how we use trigonometric identities. You have seen some examples of this all the way back to chapter 1. And a lot of these fundamental identities that we're talking about today, we actually learned in chapter 1. And so we're going to talk extensively about those in chapter 5. And really, chapter 5 is where some people kind of start to separate themselves in terms of how hard you're willing to work, because this chapter is one that can take a little bit of time in terms of our homework and things like that. So I want to start by introducing a new set of identities, and that's what we call our negative angle identities. All right, and to kind of get a picture of what this means is that, like, if I have an angle that let's say it rotates all the way out here, and a point on the terminal end of this angle is, let's say, -3, 2. Okay? And that's theta. Then negative theta would be the angle that just goes in the opposite direction, the same number of radians or degrees, and gives us a terminal point at -3, -2. Okay? I'll even zoom in there so we can get a picture of that. This would be the angle negative theta. Now, what we want to know is like, all right, what does sine theta equal in terms of sine negative theta? Are these going to be the same, right? Well, you can look at it and clearly see that since sine theta is going to be well, if we would drop our right triangle, that's what we would call our R. R would be 2 squared plus, R squared would be 2 squared plus -3 squared, which would be 4 plus 9, which is 13. So R is the square root of 13. In this case, we drop our height down here. You're going to get the same R in both, right? Because you still have -2 squared plus -3 squared, still 4 plus 9, which is 13. And then you'd square root. So R is the same in both of these. So sine of theta is going to be 2 over the square root of 13. And sine of the angle negative theta is going to be, well, -2 over the square root of 13. So you can see they just differ by a negative. So to generalize this relationship, the identity is going to be that the sine of negative theta equals negative sine theta. All right? And you can see that here. The sine of negative theta is this times -1. If you threw a -1 in front of the 2, it would be equivalent. So that's our first negative angle identity, and we can find the rest of them in terms of cosine negative theta. And what that equals, that actually is just going to be the cosine of theta. Notice -3 is the same. You're using your x-coordinate to find cosine. And then third, the tangent of negative theta is just equal to the negative tangent theta. Okay? So those are 3 negative angle identities. Technically there are 6 because you also have the cosecant, secant, and cotangent, but those work the same as sine, cosine, and tangent, respectively. So that actually describes the last of the identities that we need to know for this section, 5.1. We have the negative angle. I'm actually going to zoom out a little bit, and I'm going to give you a list of all the identities that you will need to know, and most of these came from Chapter 1. If we look at, fit in there. There we go. If we look at the reciprocal identities, we've been using them a lot. The quotient identities, we just talked about those in section 4.3 when we talked about graphing, cotangent, and tangent, right? And now the Pythagorean identities we also used. In fact, you use these on the Chapter 1 test, okay? There's a question where you had to do very similar things to what we'll do in this section. And now we add our negative angle identities. Forgot that one. But you could go ahead, take a second, pause it, write it down. What I would do is I would start an entire list of these because we're going to add several more identities that we're going to need to memorize and be able to work through as the semester, the rest of this chapter. So as the rest of this section is going to show, we're going to use those identities we just looked at, but we need to kind of think about what some of these terms that we're going to be seeing in Chapter 5 mean. So some important terms that we just are going to use on a daily basis, something like the term verify. Verify is basically like proof. So verify means proof. Okay? It means prove one side of an equation equals the other side. Okay? And an example that we might see that is something like this. If I said, express the cosine of x as the tangent of x. Well, what that means is, that means show cosine x equals something with tangent. We don't know what it is, but we use our trig identities to find something with tangent, some mathematical expression that contains the tangent of x. Okay? And what that actually is something that we'll learn later in this chapter, but we could actually show later on in this chapter that the cosine of x equals plus or minus the square root of the tangent squared x plus 1 divided by the tangent of x squared plus 1. So, yeah, this is something that we will actually show in another section in a problem. But for right now, we just need to understand what this terminology right here means. Express cosine as tangent means tell me that the cosine equals something with tangents in it. Okay? Here is another example of what we were just talking about. So let's say we want to express, and these are what some of your homework problems are going to say, express the tangent of x divided by the cosecant of x in terms of sine of x and cosine of x. All right. So how you might do that is you would start with what we're given. We're given tangent of x divided by the cosecant of x. All right. Well, these both have identities. There's a quotient identity where we can change tangent into sine and cosine. And there is a reciprocal identity where we can change cosecant into sine. So what we might want to do is we'd start with that the tangent of x is sine over cosine of x. Right? And then that is all divided by, so tangent divided by cosecant is tangent divided by 1 over sine x. Okay? And these are, again, the fundamental identities. These are the ones that we need to know backwards and forwards. So later on, when we look at sine x over cosine x, we need to see tangent when we look at this. Okay? When we look at 1 divided by sine x, we need to actually see cosine of x. All right? Now, if I was just going to simplify this, you might just multiply by sine x and by sine x, and then you could say that this is actually equal to sine squared x divided by cosine of x, and that would get us right back to where we're at here. Okay. So that's just kind of the type of thing that we're going to be doing, is just using identities to rewrite expressions. Another example, using that term we just looked at, verify the cotangent of x times the secant of x is actually equal to the cosecant of x. So we need to use trig identities, and we are typically only going to use one side. So we're going to look at this left side, the more complicated part, and we're going to try to simplify this down into just cosecant. All right? So we're not going to do, there's no algebra here. You don't add to both sides. You can't divide both sides. You just work with identities on one side of the equation. So cotangent of x is cosine x divided by sine x. Okay? That's what cotangent is, using the quotient identity. Secant of x is 1 divided by the cosine of x. Okay? And we're still going to show that the left side equals the cosecant of x. Some of you might already see this. Cosine divided by cosine is going to be 1. So what we really have here is these cosines divide out, and you're just left with 1 over sine x, which is, of course, the cosecant of x by the reciprocal identity. So, we get into a lot more complicated ones, but this is an example of how we verify an identity. Of course, these 3 dots, if you don't know what those mean, those just basically mean that, hey, we have proved the left equals the right. Okay? And once you write those, you're good. Okay? Last thing we want to do is look at an example, and this is the type of thing that we've done a lot of, is using identities to find we could say the tangent of theta and the sine of negative theta if sine theta equals negative 4 over 5 and theta is in quadrant 4. For the sake of time, I went ahead and did this problem, and I'll just kind of explain my thought process. First, I looked at my identities list, and I said, if I start with sine, I can find cosine, and then I can use cosine to find tangent just based on how I move throughout my identities. So the Pythagorean identity gave me that cosine is positive 3/5 in quadrant 4. And then I used that with tangent, the quotient identity, to find that tangent is now negative 4/3, again, in quadrant